why do I want to talk about Docker? Before I start, I want to tell a bit about myself. I'm more of like a front-end developer, and I've been working with the front-end technologies for, I think, like 3 years now. So as a result, like I haven't really worked much with deployment tools or with container technologies at all. It's only like due to my current assignment that I've started working with it, and I find it like really, really awesome and exciting. And that's why I wanted to share like this excitement with you as well. The more I use Docker, the more I love it, and I hope that you'll come and learn to love it as well. So yeah, the objectives for today's session, what I hope to achieve out of this today is wait, again, like just before I continue, you guys can see my screen, I guess. Oh yeah, you can, okay, cool. So yeah, so the objectives of today, hopefully, is that everyone here can get like the basic understanding of containers and why they're so common nowadays. All of us will be able to create and run our own containers from today. We'll learn how to manage different services using Docker Compose. For people who are like very, very beginners, who are just starting out, this is like perfect for them. Hopefully this is gonna be able to reduce your learning curve and help you kickstart your Docker development using Docker tomorrow. For those of you who are a bit more advanced and who have used Docker for a longer period of time, already kind of like, like a bit more savvy in this, hopefully this can be a nice refresher on your fundamentals. And something that I really want you guys to take away from this is to know that, hey, Docker is actually a very, very simple technology. It's nothing to be afraid of. It's not intimidating. It's simple and it's going to be fun. All right. So today's structure, the way I'm planning to structure this entire series is initially I'm going to talk a bit about what Docker is, and we're going to understand what are images and what are containers. And after that, we're going to explore the Docker CLI on our own, and that's going to be our first hands-on. Okay, so once that's done, we're going to learn how to create our own custom images with a Docker file, and that's going to be our hands-on too. We're going to go on to talking a bit about networking and using Docker volumes. And after that, we're going to simplify this entire process using something called Docker Compose. And that's going to be our third and final hands-on. So once that's done, I'm going to explore a bit more advanced Docker Compose use case, where I'm going to deploy a full application, hopefully if the server is working. And after that's up, then I'm going to explain a bit about what's under the hood in Docker. So throughout this journey, I'm going to go back to this requirements again. Please try to go into this Mentimeter link. The QR code is here. Try to go into it with your phone. It has like set of questions for you to answer as we go through the session. And it's kind of like a health check on how we're doing. Okay. Yeah, so we are back to this. So I'll just walk briefly through what the links are. So the first one is like the hub.docker.com. It's like a Docker repository. For those of you who are used to working with Node.js, it's kind of like the NPM repository. For those of you who are working with maybe Python, it's like pip or Maven, like it's like a global repository for your project. Then the next link that you have, the labs.playwithdocker.com. So that's going to be the, hopefully that was the plan to use. That's a remote server where people can access and have access to an entire container for you to work on. It's a server where Docker is already pre-installed. The following link is my own repository. It's like a very basic demo tutorial on how to work with Docker and how we can deploy a basic application. The following link is the Menti, where we're going to walk through some stuff. It's a questionnaire for you to fill in. The docs.docker.com, it's the official Docker website. The next link, Intro to Containers, it's a series of articles written by this guy called Brian Holt in Microsoft, and that was like very helpful for me on my own journey. The next one is a cheat sheet. because we're using the CLI, there are a lot of commands that we don't really remember all the time. So having a cheat sheet helps. And the final one is like article to like the evolution and the history of containers. Speaking of evolution and the history of containers, quick question for you, just to think of it, like how old do you think the concept of containers are? Come on, you guys can like write something. 2012. Anyone else? Wow, you guys are actually a lot more knowledgeable than I am. All right, yeah, you're right. Imagine my surprise when I, like during the research of this, I found out the idea was actually there in 1979. And I was like, holy, what the hell? So yeah, that was like a really interesting thing for me. Like even though like it's really, really popular nowadays, and I think of this as like something new and upcoming, but it's so old. So yeah, the concept started in 1979 with Unix P7, where they introduced this concept of chroot. So I'll expand on that a bit later. And like in 2008 with LXC containers, we pretty much had all of the features that a container technology needs. And then eventually in 2013, we ended up coming up with the Docker, which kind of like simplified a lot of the setup process and made it accessible to like junior devs or people who are just starting out like me. And then we have Windows containers in 2016. And yeah, even though the support for Windows is not that nice, it's wonky. I myself use a Windows computer and it's kind of like annoying to work with Docker. But now with Windows Subsystem Linux 2, the WSL version 2, it's quite seamless. All right. So why do we need containers, and what's the story of why are we moving to containers nowadays? Again, like historically, just by looking at it, whenever we end up creating an application, and do correct me if I'm wrong here, but this is like my understanding of the history, right? So whenever we ended up like creating an application and we wanted to deploy it on a bare metal machine, we would have to install our own operating system on the machine. And on top of that, we would have to install our libraries, and then we have to install our app, which was running on those libraries, right? And deploy our application like that. And imagine like when our applications are working on different versions of the libraries and we have to support both of them. At the same time, maybe one application is using one OS, but the other application I need to deploy needs to be running on a different OS. So with just having like one bare metal machine, it's becoming like more troublesome, right? We can't really end up doing that. So that's when the concept of like virtualization came into play, where you would have the operating system. On top of that, there would be another layer of process called the hypervisor. And on top of the hypervisor, we would run virtual operating systems or virtual machines on top of that. And that would, so each virtual machine on top of like my actual machine would have its own operating system, have its own kernel libraries, have its, basically, it would have this like own set of like softwares, and that would end up creating a lot of bloat. So we would run out of resources on our machine very, very fast. So that's when like container technologies came into play. So what happened over here is like, hey, we still have our like operating system, but on top of our like base operating system, instead of the hypervisor, now we have like another process, which is the Docker daemon or the Docker engine in our case, and which allows all our applications to run in isolation with their own internal libraries, and depending on the operating system kernel itself. Right, so this is like the very basic idea, and we're gonna explain this even more further. So yeah, whenever we're working with the Docker, we keep listening, hey, build that image, or hey, run that container. And when I started out, the concept of images and containers would like confuse me as well. So the basic way to look into this is thinking of a Docker image as like the installer, So, like when we want to install a software, we double click on the installer, it runs through the installation process, and then the application is installed, and it creates a .exe file for us to run. So that .exe file, you can think of it like a container, and the installer as the image. So thinking of it like that, you can think of the container as an instance of our image, right? So the definitions you see on the screen, I picked them up from the website, Docker docs. And like it basically says that an image is like the smallest unit of software that packages all the dependencies internally. It's lightweight, and it's lightweight because it shares the machine's operating system kernel, and it doesn't need a new operating system per application. It's secure because it's isolated. And whenever an image is running during runtime, it creates a container. So that's like the .exe file, right? And then we have Docker Hub, that's like the repository for all of Dockers. So yeah. Moving on. So I'm showing this to you again. So we have like our infrastructure. So this is like the base hardware on top of which our host operating system is lying. On top of that is our Docker daemon, the Docker engine. And on top of that, we can see that we have multiple applications that are running that are using the host operating system, but are completely isolated. So the libraries of app A does not interfere with app B or with app C. They're running in isolation. So one of the advantages of doing something like this and having like a central Docker Hub repo is developers can build something and push through the Docker Hub. Our build tools can pull it from the Docker Hub and build our application at the same time and push it into our deployment service. So it's like one unit of software that can be shipped everywhere. It makes shipping so easy. Okay, with that out of the way, let's look into some of the basics, some of the basic commands of Docker. So what you see on my screen, I'm just gonna run through them, explain them one by one. So those of you who have used Git, Docker pull command is like the Git clone command. So whenever we're doing a Git clone, we clone a repository from like GitHub or GitLab or Bitbucket into our computer. When we're doing Docker pull and we're passing in the image name, it pulls the image from the repository into our computer. When we run Docker images with the S, we can get to see a list of images that is on our computer. We can remove an image that we have downloaded using the command docker rm and then pass in the image name. We can delete multiple images using the docker prune command. And the flag, there is a flag, or basically options like what kind of images do you want to prune. We can create our own images or build our own images using the docker image build command. And that's kind of like the basics for images. So that's like our installer, right? So now let's look at the container. Those are our .exe files. So for a container, we can create a container from an image using the docker create command. The -d flag means that it's gonna run in the background. So it's not gonna so whenever we are on a terminal, it's gonna eat up our, it's rather than starting on the same process as as the place where we're writing our commands, it's gonna run in the background. So it's running in detached mode. We can pass the name of a container using the -- name. We can pass in the port. It's not like the port, it's like publishing, connecting our local host port with a container port. This is important, and I'll explain to you afterwards why. We can pass in like whatever image we're building on top of is an image name. And we can also pass in an entry point. I think we can't do this here. This is on the next one. Yeah. So the docker run command is like a docker create, but it starts the container immediately after creating it. The docker exec command means that we want to go into a container that's already running. The Docker PS lists all the containers that are there, all the running containers, and the -a flag allows you to list all the containers that have been created on your computer before. We can also remove a container using Docker container rm. We can either pass in the name of the container or the container hash. So now that I have walked through all of this, I'm just gonna do this again in the terminal. So let's do this. I think you can see my terminal right now, or are you still looking at my Chrome window? I usually get confused with this. Okay, cool, thanks. All right, so let's look at our images, for example. Say I want to pull image from Docker Hub. Is there something like that? Oh, there isn't something like that. Okay, let's find some images to pull. Like I said, we can see all our images from Docker Hub. And we can search for stuff. Hey, this is our Hello World image. And okay, so I can just do Docker pull hello world. So you can see it's downloading the image. So now that I have the image, I can list down all my images. Okay, so these are all the images on my machine right now. And you can see Hello World is also there. This is the one I just downloaded, I think. No, actually I had it long back. Okay, you know what? I'm just gonna remove it for you. So I can also remove images using Docker image rm. Oops. There we go. So you can remove images using the hash or the name as well. So now that it's not there anymore, I can pull it down again. All right. So if I list them now, see, we have it. All right. So when we do Docker images, we have like some of the information. So the first row tells us what's the name of the repository. In this case, is Hello World. The tag represents what version of the image we're downloading. So if we don't mention a version, it will always download the latest version. The image ID represents a hash of what the image is. And the created ad tells you when it's created. So this image was created 4 months ago, and also the size of the images. All right. Okay, now that we have started it, let's run it. Docker run hello world. Okay. As you can see, I ran the image. It created a container, and then I can see the output of the container. So after the application has finished running, the container is going to stop. So if I do Docker container, if I do Docker PS, I can see this is my list of containers, and there is none of the containers are there. If I do Docker PS-A, I can see, hey, I ran this container just now. So what happened over here, it ran the container, and once it finished executing, it stopped it on its own. If a container is running in the background for a long period of time, it will not finish executing. So to give you an example, I think I have Mongo stored in my computer. So let me just take a look at that. Okay. So you can see now that I did Docker PS without the -a flag, my Mongo database is running. because it's always listening to something. It's listening on port 2717. Yeah, so it's listening on port 2717, and it's running at behind the background. To stop it, I have to manually stop Docker container. I think it's Docker container stop or Docker stop. I can't remember myself. 63.6. Yep, the container has stopped. And you can see that it's not here, even though I stopped it. This is because when I ran the container, I ran it so that it will stop when I stop. It will delete itself when I stop it using the --rm flag. All right. Okay, now that we are okay with the basics, let's try to get our hands dirty with some hands-on exercises. I'm gonna go into the server and see if it's working right now. Okay, so it's running for me. I will ask you guys to go to this link and see if you can access it. Okay, cool. If it's working for all of you guys, it's great. Okay, awesome. I think their server is back up again. Great. Okay, so this is going to be your exercise now. I want you guys to list a number of images. Of course, there is no way for me to check. But yeah, just try to get familiar with the tool on your own. You can I am going to, this is troublesome. Wait, let me try to. Okay. Can I make this bigger? Then I can show you the thing on the slide as well. Guess this is the max. Okay. I think it's too small for you guys to see. Yeah, you need to have an account on Docker Hub. So yeah, you know what? I shared a link to my GitHub repo initially. If you guys can download the repo from there, that actually has the slides for you. So it's easier for you to wait. Hey guys, just download my repo. So this is the repo. If you go into it, if you clone it on your own, the PDF is actually the slide deck that I'm going to use throughout the session. I should have shared this earlier with you guys to smoothen the process. But yeah, download this and you will have access to all the resources on the slide. Because I think it's a bit difficult for me to share my screen like this with you. Excuse me. Okay, so for the first exercise, I think we're going to spend a bit of time for everyone to get set up and have it up and running. So let's spend around 5 minutes on this. I think that should be good enough. Okay, so Ranjani, you don't have to have Docker on your machine. You can just use the server as long as you can log in with your account. Okay, so I'm not going to cover how to set up locally because that takes up too much time. We don't have for this session. And it's different on every machine. Like if you're running it on Windows, it may be different. Does each Docker have its IP address or use the IP of the host machine? Okay. When the networking is set up, it's completely isolated. So internally, it will have its own IP addresses, but you will not have to set that up. Okay, so I will go through the thing with you. So once I log in, I have this screen, right? And let's see, the exercise will be, wait, what? Okay, wrong browser. So once I log in, after I create a new instance, I get access to my own dedicated server. Inside the server, I also have the SSH, which means that I can SSH into the thing directly. So if you are on your terminal, if you're on a Mac, you can SSH into the container directly and internally. Once you go in, we can see everything that's there. So if you don't want to use the server, you can SSH into it. But for this, I will be using the server shell. Okay, so what we want to do is basically want to list the number of images. So hey, Docker images. There is none initially. That means it's 0. Then we want to pull like 2 images. One is Ubuntu and one is Mongo. So I don't know what the name of my images are. So I can just go to my Docker Hub and then test, okay, what are my images? So I can search, hey, Mongo. Okay, Mongo is just called Mongo. And Ubuntu is also just called Ubuntu. So I can just do this. Docker pull Ubuntu. and then docker pull Mongo. Yeah. So to make sure that, hey, my images are there, I can do again Docker images, and I can see, hey, I have Mongo and Ubuntu now. All right. So now that I have them, let's try to create a new Mongo container. Okay. So how do I create a container? I can do Docker create, but in our case, I want to run the container at the same time, right? So for this, I'm going to do Docker run, and I'm going to not pass in the detach flag so that I can show you what goes on, but this might be a bad idea. Okay, so here's what's going to happen. I'm going to SSH into the server. And because I SSH'd in, I should have my images as well. Then I can run Mongo. Let's give it a name. Let's call our container MongoDB. So one of the things I want you guys to do is to be able to map the ports. So the first is going to be the host 2717 to 2717 of the container. Sorry, 017 of the container. The reason behind this is we want to talk to our local host 27017, and I want the response to come from 27017 of my container. And then I can pass in the name of the container, which is Mongo. And we can see that our process has started, but like you can see, like it's running here, and I don't have control over this thread anymore, right? So I will eventually have to stop it. So it's shut down, and then I have to start it again. But because I already created the container, I can actually list down the container using docker ps -a. We can see, hey, MongoDB is there. This is the name we gave. Did you look at that? The ports are not published. That's weird. RM. Just give me a minute, guys. Let me test something out. Did I make a mistake just now? 27017. Okay. So I can stop this C7 and you can also list your container using the command docker container ls. And then I can start it again. Docker start MongoDB. Now we can see it's running and it's published on ports 2707. So to make sure that, hey, it's running, I can just do a very basic curl command. Localhost to 27017. And we can see, hey, this is a response that I get from my container. And this also means that, hey, when I went into my host port, I was actually able to talk to my container port. All right. And yeah, the final step of this would be to stop my running processes, MongoDB, and I can also remove it, MongoDB. All right. Since we're done with this, can we head to Mentimeter and do a health check just to see? We'll just open Mentimeter on my other monitor to see the status. Okay, it seems like some of you are still So for those of you who are not sure how this works, actually I should have had a deck with the answers. Oh well, I think I will be able to, I may change the slides a bit and update to my repo afterwards as well with the solutions. Anyways, so okay. So the purpose of hands-on one, getting familiar. So what I want you guys to get out of it is like to be a bit comfortable using the Docker CLI. You guys are still on the first slide of Menti. Okay, so it should be on this slide. And I'm going to skip this, and skip this. Yeah. So you have to click submit to go here, and then you have to wait for it. Okay. That was a quick detour. All right. Coming back here. So yeah, hopefully you guys know how to pull images from the remote repository, remote hub now. Can list the different images, can list your containers, and can create a new container. We can stop and remove containers and remove images as well. Okay, so with that out of the picture, I don't know why this bar is still there. Okay, yeah, I think that's better. Let's talk a bit about the Docker architecture a bit more in depth. So we have the Docker client. So think of the Docker client as all the commands that you're running on your shell or on your terminal. And whenever you're running your commands, they interface with the Docker daemon. And the Docker daemon is the one that does all the work behind the scenes for us. So this is the one that handles like pulling images from the repository or the registry. It's responsible for building our images and creating our containers and running them. So once you stop a container, you can do a Docker container ls-a, and then you can start it again using Docker start and the name of the container. Okay, so with that out of the way, let's try to build our own custom image, right? So if we can't build our own image, it's not that useful. So, okay, so how do you do that? The way to do that is with this command. We call it the Docker image build, and we pass in a tag name with the -t. So that's going to be the name of the image we're creating. And we, on the last parameter, we pass in the path to the folder with a Docker file. So what is a Docker file? A Docker file is a manifest, which is basically a set of instructions on how to build an image. So images usually build on top of one another. So we build on top of a base image, and we indicate the base image with the from command. And I'm not going to walk through all of them because some of them are actually deprecated. This was on the previous Docker file, but I just pulled it off from like the Docker cheat sheet. But some of the important ones are from, copy, run, worker, CMD, and env. Excuse me. So the from command is responsible for identifying your base image from which to build on top of. The copy command copies things from your host machine into the container. The run command runs shell commands on your container. The worker sets the default working directory. The CMD is what's going to run when you run the container. And the env is like to set any environment that we need in our image. So with that out of the way, let's look at a basic example. For example, say we are building a Node application. And the way you would usually do it is, hey, I clone a repository, or I have my own repository, and on top of that, I do an npm install, right? So what I do now, I build my Node base image is, in this case, I'm copying it from Node latest. So Node latest is an image that you can find in Docker Hub, which already has Node pre-installed. I set my work directory to /app. I copy my package.json and packagelog.json from my host machine into the container working directory. So the ./ is representing the /app of my container. Then I run this command npm CI inside my container. So this ends up installing all of my Node modules. And once I do that, I copy whatever else is left from my current directory in my host to my working directory inside my container. And after all that is done, I can just run the command node app.js. So once I do this, the image is built. And once I run the image, it will run this command by default. Something to take note here, if you are familiar with like Node applications, once we're doing this copy command, we will end up copying the Node modules as well. And that's something we don't really want all the time. So to prevent that, we have something called .docker ignore or Docker file ignore. I can't remember the name right now. It's like a .git ignore file, and whatever folders or whatever path you put inside, those files will not be copied over to the container. I hope that's clear for you guys, because now it's time for you to do hands-on too. Okay, so the purpose of this hands-on is for you to build a custom image. And what we're gonna do is basically create a folder. And inside that folder, we're gonna create a text file with the world, with the text hello world. And after we do that, we're going to create a Docker file in that same folder. And inside that Docker file, we are going to write our commands such that it copies over this file from our host machine into our container. And then in the command step, we're going to write something so that once we run the container, it ends up echoing the contents of this hello world.txt. Okay. So yeah, let's spend maybe another 5 to 7 minutes on this. Okay, let's spend until maybe 7:30 on this. And I will start working through the solution at maybe 7:27. I'm just going to go through the chat to see if you guys have any questions and try to address them. Okay. Okay. Okay, so while we're working on this, I'm just going to go through a quick recap of the architecture one more time. Actually, let's go back to this again to understand what's going on. Oh, my bad. The command is echo hello world. Do hello world.txt. It's not cat. And I think I swapped the order. Anyways, so just to give you a quick recap again, what is a Docker image? A Docker image is like the installer that you use to install software or an application. And after the application is created, you can think of the .exe file of the application as a container that can be started, that can be run. So once it's running, we run it by container start. And once we close the application, we do container stop. So once an image is running, it creates a container. And the image itself is the standard unit of software, like it contains all the dependencies as well. Okay, there is that, and I think there may have been a mistake over here. Yeah, this is most likely cat. Okay. So you can think of like a Docker image as like the template on which the container is built. So container is like the instance. So if you're looking in terms of programming or in terms of like OOP sense, you can think of an image as a class or the blueprint, and a container as the instance of that blueprint that's running right now. Okay, with that out of the way, I'm gonna go through the exercises with you now. Okay, so let's see. Okay, I'm on root. I'm going to create a new directory, say custom. Going to custom. And once I'm inside, I'm going to create a new file. So it can be anything, you know. So maybe I love ice cream. There we go. And I call it icecream.txt. Okay, we have a file called icecream.txt right now. So let's create a Docker file now. So the first is going to be the base image. In my case, I'll just use Ubuntu. Then I will set our work directory. This is not necessary, but it's a good practice. And then I'm going to copy everything on my host. Oh, okay. Everything on my host into my container. And finally, I will have my run command. Working directory can be anything. Basically, it's going to be the name of your folder. So if you want to call it custom, it can be custom. It can be app. It can be basically anything. And yeah, I don't want to run anything actually. It's fine. And then it's going to be my command, which will actually get executed. So I think this is the place where I kind of like messed up with the cat and the echo. So I want to list out the value. I think I called it icecream.txt. .txt. That should be it. So now that I have my Docker file created, I can build it using the Docker image build. And I will call it, you can call it whatever you want. In my case, I'm gonna name my image ice cream, and then I'm gonna pass the path to the folder which has Docker file. In my case, my current folder has the Docker file, so it's just gonna be a dot. So you can see it built the image to make sure that yes, it's there. I can run Docker images. So you can see it was created just now, 9 seconds ago. And once it's there, I can run it, but I don't want to keep it. Actually, no, you know what? I'm gonna keep it. Let's name let's give it a name, ice, and pass in the name of the image. It's ice cream. Yeah, that should be it. So you can see once I ran the thing, it listed out the command, and then it stopped on its own because it finished execution. So if I list all of my containers, you can see, hey, this is my container. Actually, can I? Yeah, my screen is too small, but you can see the name is ice. All right. So let's try to go into this again. So the -it allows me to interactively go into it, and then I can pass in the name of my container, the image on top of which I want to build my container. It was called ice cream, and I need to pass in an entry point on which I want to interact with it. Okay, so now I'm inside a shell inside my container, and I'm inside the working directory. So if I list down the print working directory, you can see it's /app. This /app is the same. No, okay, it is the same as my Docker file. So you can see this is like all the Ubuntu root folders and files. In my case, I created a new directory called app. And inside app, I copied my icecream.txt and my Docker file. All right. So that's gonna be the end of hands-on 2. So hopefully now you guys know how to write your own custom Docker file and how to build your own custom images. With that out of the way, can we have another health check, please, and see where we are right now? So please go to Mentimeter again, and you will see a new question on your screen for you. Okay. I see your question, but it's a bit hard for me to debug from here. Okay, tell you what. Maybe one of my colleagues will help you with that question, or maybe you can wait until the end of the workshop to ask me, and then I can walk through with you with that. Cat will be in lowercase. So yeah, that should work. We still have quite a bit to go. Okay. All right. So can you back up a running container? Once you create a container, it's always going to be in your machine. So there is no need to recreate it every single time. You can just start a stopped container whenever you want to. So I hope that answers your question, because I don't understand what you mean by redundancy and backing up a container. Anyways, I'm gonna try to move forward. Okay, so let's talk a bit about networking and volumes. So, like isolated containers, when they're running, it's not really very useful to us. What we want is like, maybe we have like different containers running. Maybe we have a container that's running a database, and we have a container that's running our application, and our application is to talk to our database. And if they are completely isolated, there is going to be no interaction between the two, right? And that's going to be very, very, I don't know, like not very useful to us. So we want to be able to set up like this kind of like network between them. And on top of that, like imagine like when you have a container and we're running a container as a database, and the database is recording data, right? And if we remove the container, all our data is also removed along with the container. That's like very scary, right? We don't want that. Like in our production applications, we're recording maybe like thousands of records, and we want to be able to store those records, or maybe move them to some long-term storage, or move them between machines. So to address that, Docker provides us something called volumes. So volumes allows us to bind our container with our host machine. All right. So let's look at how that will work. So for Mongo, if you guys are not aware, all of the data that Mongo creates, all of the container that Mongo creates, all of the data that Mongo creates, it's stored in this file, in this folder, /data/db. But whatever is getting stored there, I want it to store on my host machine, not on the container itself. So I'm going to bind it to my own folder in my host machine. So to do that, we can create a folder. hey, I'm just creating a new folder called /var/codedb. And then once I do that, once I run my Mongo image, I can say, hey, Docker run in detached mode. I pass the name as db, and then I pass in this flag called -v. It takes in two parameters, the host, which is on the left side of the colon, and the container, which is on the right side of the colon operator over here. So it maps whatever is on the right side, whatever path is on the right side, to whatever path is on the left side. And then I'm connecting the ports, hey, 27017 of my host machine to 27017 of my container machine. And then I pass in the name of the image that I want to create a container out of. So in this case, it's going to be Mongo. So I want you guys to follow this like step by step first. Actually, yeah. For this step, I'm gonna do it on my own, and hopefully I'll walk you through what's going on, right? So let's do this. Okay. So this can literally be anything. I'm calling it /var/codedb. You can call it just db as well. Actually, I'll just call it just db. Oops. Where did it go? Oh, there it is. Okay. Actually, I'm gonna move it here. There. Okay. So I end up getting distracted by the chat, so I'm just gonna ignore it for now. I will let my colleagues answer you in the meantime. Okay. So I can create a new folder called db, and then just to make sure I have Mongo. Mongo is not there. So this is gonna be something interesting. Just gonna copy this. No, 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 no. But this is gonna error out because I already have a container that's running. So with the same name, Docker rm -f b49, go away, I'll go back to this and then run it. Okay, so now our application is running. Basically, our container is running. Yep. So I'm just going to clone my own repository. Please do this as well in your own playground. And then inside my repository, I have something called the server folder. Oh, I have to pull in. Okay. So inside the server folder, I have these 4 files. Actually, for those of you who are not very familiar with the shell, you can just click on the editor. And over here, you can see all the files. So let's look at whatever we have in our server. So our server is basically like a few routes. And it's basically an application where we can like save our favorite quote, like whatever quote we like, we can store it into the database. And this is a REST endpoint that allows me to do that, right? So we can go to the models directory, and I can say, hey, inside the models, I have this kind of like schema, right? And I can see, hey, I want to connect to my local host, and I want to name it CodeDB. This is my package log, and I have my package.json. So yeah, it's like a very basic application. So now that I have this, let's try to create an image out of it. I'm just going to copy this. Okay, take note that I'm using Node over here because I need Node to be installed in my base image. And then I can build it. Now let's call it my server. And pass in the name, the path. In this case, is my current folder. We wait for it to download. Okay, now it has built our image. I'm just going to do a double check to see what port am I exposing it to. So my port is 8080, and I want to expose port 8080 to my local host as well. So I can run my image. I don't care about the name. I do want to run it in detached mode. I want to publish 8080 to 8080. And then I want to pass the name of my image, which I have called my server. Okay, so you can see my server is running. So what's interesting is this playground exposes different ports for us to use. It's taking a while. The network is quite slow. Yeah. I think I kind of screwed up during this. Let me try again. Oh, come on. 06BA. Okay. Oh, I know what happened. Okay. So there's this thing that goes on. I will just open my editor one more time just to show you what happened. Okay, so remember that how I keep mentioning that all the containers are completely isolated and they cannot talk to each other? If I look into my models over here, you can see I'm trying to talk to localhost, but a localhost is not defined, right? So localhost over here means localhost of my current container, and that doesn't really work. So this is the code I had inside my server. So I basically have to replace this localhost with DB because I think that's what I'm calling my database. I save it. And I have to rebuild my image. Where am I right now? My root, go back to server and build. And once I have rebuilt it, I will remove my old one. So in this case, it's going to be 06B. Come on. Okay, then I'm going to run it again. Let's try this again. Hopefully this works. If it doesn't, I think we have to create a network for them to talk to. Wait, so some of you want to look at the Docker file, so I'm just going to show it again. Ah, yeah, sorry guys, I'm getting clumsy fingers. There we go. Okay, so this is the Docker file of the server. It's a node application. So I pull from the node base image. And then this is my, I set my work directory. I copy my package.json and package lock into my work directory. I run my npm CI inside my container. I copy everything on my current folder inside my host machine into my container. And then I run this npm start inside my container. Okay. Okay, so now we have to work with Docker networks. So what's going on is like, I want to talk to my Mongo database from my server, but I can't end up making them connect to each other anymore, right? We can't, as in that's not happening because no matter what I do, if I got a local host, it's going to be local host of the server itself. If I call DB something, it's not able to resolve the DNS of DB. So what we can do is we can create our own network. Actually, I don't even remember the command for this. You don't need to get into the project folder to do npm start because your work directory is already set. Just gonna answer some more questions. This is the same, but I think this is something. Are you inside the server folder? So I'll show you, this is my current folder right now. You have to be inside this folder to be able to do that. Okay, cool. Okay, this is almost 8 and I have a lot of things I want to walk through. Okay, so here's what I'm going to do. Basically, I'm going to explain what's going on and I'm going to skip the rest of the hands-on for now. So what ends up happening is I have like 2 different containers. I want them to talk to each other, but to talk to each other, it needs to know the IP address of one another, right? So so there is a command called docker inspect, which I can use to inspect any of my containers. So for example, I want to inspect my MongoDB. I don't even remember the names. Yeah. Why is this happening? Copy this. Docker inspect. There we go. So every single container has their own internal IP, right? So you can see my current IP of this container is this. So the IP address of my Mongo is not being resolved from the IP address from my the other container that I created, which is like my server. So I need to be able to sync them up together. And this process can be quite annoying if I'm doing it manually, as you can see right now, because you have to remember a lot of different things. So to simplify this process, there is something called Docker Compose. And Docker Compose basically handles setting up of this internal like network system, as well as it allows us to serve multiple services at the same time. So an example of that would be, say right now I just have the database and I only have my server. Say you want to set up like another container that's going to be maybe your in-memory database, either Memcache or Redis. You may want to have like different microservices that are on different containers as well, and you want them to start up in a certain order. So to do that, all of them manually takes a bit of time and effort, and it becomes like really hard to maintain the more as we move along. So to stop that from happening, or to help developers do that and make it easier to maintain, Docker allows us something called Docker Compose that reads a .yaml file, which is also like a manifest and like a set of instructions, and handles creating of those containers and containers and services on its own. So this is like the format of a Docker Compose. So just by looking at the format, you can see the first line, it's like the version, what version of Docker Compose we are looking into. And following that, we have a list of services. In this case, we're gonna have 2 different services. So the first service, the key over here, the image takes in what image you're going to run over here. If the image is not there and if it's not in the registry, you can pass in a build context that's gonna direct you to the Docker file. And it's going to depend on this service, which you are defining here, which means that the database has to start before the service has started. We can also pass in like environment values with like the different strings or whatever environment we want to pass into. In this case, I pass in the Mongo connection string. Kubernetes is built on top of Docker. So I have not explored that yet. But again, like I'm getting distracted by the chat. I'll answer your questions afterwards. Yeah, so inside the DB service, we can see, okay, my image is going to be Mongo. I don't need to pass in a build context anymore because I know Mongo actually exists in the registry. And then I'm going to bind to the volumes, which is going to be the source of, this is my host machine, and the target, which is going to be my container path. And I wanted you guys to do this on your own. Try to do it on your own time. But in the interest of time, I'm just going to show you the final outcome that I actually had planned to eventually go into. Okay. So I'm going to revert back to whatever was there before. And I'm going to check out to this branch, which will actually have the final thing. I think I called it Docker file, if I remember right. It was a hard head. I don't know what didn't work. Okay. So let's explore whatever I have on this branch. And I'm just going to walk through whatever is there. So now I have a new folder called the client. And inside this client, it's a React application. So the React application itself is like a very basic app, which is like the UI for our code, the code application that we just built. So let's look at the Docker Compose. Actually, let's look at the Docker file for my client first. There we go. So we can see this Docker file is a bit more complicated, and I'm going to run through this a bit faster, but bear with me. So what I'm doing over here is so whatever I need to do over here is basically I end up creating my own, I use my base image and I call it builder. And then I, again, like assign my working directory, I copy my package.json, and after I run npm CI, I copy over all the folders, right? And then I do npm run build. So this ends up creating a static dist folder, and that's the only thing I need. I don't need the rest of everything that was built until now, right? So I have all my node modules and my entire source code, and all of that is like completely unnecessary for me to deploy the application. I just need my dist directory. So over here, what I end up doing is I have another from over here. So this is like I'm building on top of whatever I built over here. So again, so I'm going to start my application from Nginx. So I pull Nginx, that's my server. I run some commands, some Unix commands, and then I copy whatever was there that was created in this folder, like in this build, in this folder, the build directory. I copy everything over to my Nginx over here. That's like the default folder from which Nginx serves assets. And then I copy my Nginx configuration as well. And then I copy some more files. I run some files. And finally, I add in my entry point and add in my command. So this is like more of a convoluted Docker file on a multi-build process, but the basic idea is still the same. We already saw what our Docker file on our server looks like. this is like very, very simple. Let's look at the Docker Compose. So now I have 3 different services. One is going to be my server, one is going to be my client, one is going to be my database. Take note, in this database, I'm not binding the volumes, but you can bind the volumes if you want to. So my server over here depends on my database. So my database needs to be running before my server is running. My client over here depends on my server. So my server has to start before my client service is up and running. I pass in some environment values, Mongo connection string, and in this case, the base URL. I connect my ports. I publish my port only to the client. My server is not talking to my local host anymore. So what's going to happen right now is my client is going to talk to localhost, and that's going to be my only entry point. And then my client is going to talk to my server. My server is going to talk to my database. So once I have that up, I can use the Docker Compose command. Again, I need to pass the -et flag to run it in detached mode. And you can see it's going to build everything for me. Okay, so while this is happening, let me see if you guys have any questions. For people who have to leave, it's okay. It's a difficult time, I know. And like everyone's like working from home, most of you, and you have your own family to take care of. So it's perfectly fine if you want to leave now. But those who are willing to stay back, I'm gonna run through the rest of the session. All right. So yeah. Okay, so for those of you who are asking questions, if you want to run Puppet inside to get all the configs and setups, I think you're missing the purpose of a container in a sense, I guess. So you can think of a container as like a separate server completely. And inside that server, you can do whatever you wanted to do if you just got a bare metal server. So it's going to be like, you can treat it like a completely new OS for you. So you can do whatever you want to do inside. Can you see the Docker file from the Docker image? From what I know, you can't. Image may be built in a lot of different ways. So yeah, I'm actually not sure. I'm pretty sure that you are not able to do that. Yeah, so you can see the build process can take a while depending on what your server is. So we can see, okay, everything is up and running, and my application is running, or I can add a new code. Maybe whenever you have demo, things will go wrong. And the author maybe was a wise sage. And you can see it's here. I'm going to share this link with all of you right now. And you can go in and play with the application in real time. Multiple people can go in and like add the value if you want to. So what basically I did right now, I ended up creating a complete build and deploying it on the server just in front of you. And it took me less than 5 minutes, I guess. if you make changes to Docker container during this runtime, is there a way to retain the changes without replicating it? The changes are going to be there within the container until you delete it. So if you're creating a new container out of it, it's always going to use whatever is on the Docker file. But you can make changes to your container, and it's going to persist between different runs of the container itself. Okay. Yeah. So let's try to wrap up very fast. I really overshot. Can the modified container be pushed to Docker Hub? No, you are not pushing containers to your Docker Hub. You're pushing images. So remember that you're pushing the installers to Docker Hub, not the actual EXEs. You're pushing your blueprints, not the instances. Okay, so very quickly, what's under the hood? So Docker works mainly by using 3 basic Linux features: the chroot, the namespaces, and cgroups. So chroot is basically change root. What that means is, like, if you have a Linux environment, you can change the root of a change the root to a specific folder, the folder you're in, and that will prevent anything inside that folder having access to anything outside it. Namespaces are another Linux feature, which basically restricts you from looking at all the processes. You only have you can only see certain processes that are running on the server at that point of time. So what that means that you will not be able to interfere with other containers at that point of time. And finally, we have something called control groups. So if you have something like, if you're running an application in a container and it's eating up like a lot of memory, and you have another container, and maybe this container is eating up, say, so what ends up happening is, say, maybe container A and container B. Container A ends up eating so much resources that container B can't really perform as it wants to or as it needs to. So to prevent that, you have something called control groups, which kind of gives you different control over the physical resources of the server you have, and it ends up preventing one environment from hogging up all the resources. Okay, so there is another question right now. What's the difference between Docker Compose and Docker Stack Deploy? I actually don't know what's Docker Stack Deploy. It may be part of Docker Swarm. I have not explored that on my own yet, so I really can't answer. Sorry about that. All right. So this is going to be the end of the session. Do try to compose this on your own. And I have given you the repository. Please try to explore it on your own as well. Okay, so yeah, something else that we're doing. But before I go into this, do you guys have any other questions? No one is typing anything, so I'm going to take it as a no. Okay, so thanks a lot for joining me today and helping me share my thoughts. It was really, really amazing. And yeah, so something else I want to share with you guys is, yeah, Zenika, my company, we are a consultancy firm, but one of our core competencies is like giving trainings. And during this period of time, during the COVID-19 period, where like all of us are going through a very bad phase, we're giving remote trainings, and we're giving like big discounts to all of you. So these are some of the trainings that is coming up very soon. And we have a 50% discount on all of these trainings for every single person. But for Singaporeans and PRs, it's 75% off. And this is because of the government support that we're getting. This is a slide for you to come and register for any of the training that you think is going to be useful to you. And yeah, that's it for the session, guys. Oh yeah, you can connect with me in any of this if you want to. But I'm just going to leave this in case you want to take a look at it very quickly. Okay, so now that we're done, I will end up trying to unmute all of you. Yeah, And if you guys would like to, it'll be really, really nice to fill in the rest of the Mentimeter. And it'll be also really, really nice if you can kind of like show your videos so that I can take a screenshot and we can see that, hey, we're all in this together. Okay, how do I unmute people again? Go to chat, not chat. So I guess no one wants to show their face as much. Okay, I'm still trying to figure out how Zoom works. To figure out how I can unmute all of you. Okay, participants, right? And then unmute all. Okay, you guys. Oh God, there's so much feedback. Let's see. Okay, I'm gonna do a few snipes. This is the first page. Save. Stop. Call this 1-1. And then let's have snipe number 2. Call it 2. All right. Thanks a lot for joining me today, guys. And that was the end of the session. Please fill in the rest of the Mentimeter. So guys, don't forget to fill in the rest of the Mentimeter. That really helps with the feedback. I think I should have paced it better so that we could have done the exercises on our own. Okay, there really is just too much noise. I'm gonna stop sharing my screen now. And I'm going to mute all of us again. Okay, so the quiz is still, I think the quiz is still there. Let me see if it's there. I think I can share this with you guys. So let's see if you can answer this. Since you guys are still staying back, you can just answer in the chat if you don't want to answer in the Mentimeter. Seems like people are shy.
It's not that we are shy, it doesn't work well.
I'll just say that people are shy.
No, click on the button.
Which I'm trying.
Wait, where are we now? Okay. No, I'm so sad. No one got this right. Okay, so a Docker image is really just a template from which you can create your containers, right? It's like it's really like a class from which you create your instances. So 0 points for everyone. So sad.
Maybe the second question will be better. Let's try again.
I don't even know how do I go here. Wait, let me go back to my slides and find the link. Wait, I keep losing the.
I think maybe you need to play in Menti. You need to play the quiz for.
The quiz is not open.
Yeah, you need to play on top right.
Present?
Oh no, maybe just.
Yeah, you need to present in order to launch the quiz.
I am presenting actually.
Move the arrow.
So
Maybe go to the next slide. Yeah, this one.
Okay, here we go. 4 seconds.
Yeah, that took a while.
Matt Damon.
Okay, I have a feeling it's the 5 of us inside. Okay.
So fast to get more points.
Is it running? It is, I think.
Okay.
Tick tack, tick tack, tick tack.
Oh shit! I didn't look at the question.
Too late.
Yeah, right. Excuses.
Matt Damon.
No, I didn't put in time. Okay.
Yeah.
Okay,
Yeah,
no one
nice.
voted Matt Damon either. Cool.
Nice.
All right. Yeah, I think the last part is just to have question and answer.
Yes.
But before this,
How do I feel? I'm feeling Dockerized in my flat.
It's exactly the same what I have just written.
Hey!
Jerome, we're in sync.
Right. Maybe it's time to go for a run.
Can I do flat run?
Right. Okay.
Who is lost and might want to share why, so that we can try to explain?
Like I'm still here for a while.
And you can just unmute yourself if you want to speak. It's free to unmute.
There's a question. So usually, what is the maximum number of containers that can be run on a standard size server?
Standard size server. That's a difficult question to answer. What exactly is a standard size server?
I guess something that you will usually use in production.
Yeah, maybe Adrian can answer that.
It really depends on the size of your virtual machine or your server itself, if it's bare metal or null. It depends on the number of CPUs, depends on the size of your RAM, everything.
And it depends also on the size of the images and the container that you run.
Yeah, exactly. It depends on what kind of program you want to run in these containers.
So I'll give you an example. Once I do Docker images, right, you have a list of all the images that are there. If I do a Docker compose up, please work. So you can see like I'm running 3 different services over here, and they're built from 3 different images, the client server and Mongo. So Mongo itself, I'm taking up around 360 megs. So this is like the size in disk right now. This is not the load or the amount of RAM usage. This is just like the size in disk. Then if I look into my server, what am I calling it? Just server, my client. So you can see my client is like 100 megs, whereas my server ends up taking like 1 gig. So one of the reasons for that is I'm using something called, so I'll just show you here again, cat server Dockerflow. So I'm using Node. So Node itself is like a very big image. So in production, you would end up using something like Node Alpine. So Alpine is like a much smaller image. And one of the ways you will end up selecting what image you're going to use is you go to Docker Hub. Then you search for the image you want to use. If I go to Node, I can see, okay, these are all the images that are there, right? So most of the time you will stick to Alpine because it's like the bare minimum, but sometimes you end up using Buster as well. So Buster is not completely minimal or stripped down, but it's a bit or less like that. I will just give you a comparison. So say I copy this, I just pull this image. Oh crap, I don't even remember. Oh, yes.
Hey!
No, wait, I did log in. What's going on? Oh, hey, my bad. This is Node and that's the tag. So let's look at the images, right? So this image from Alpine is only 117 megs. This is the size on disk again. And this is the same one, that's the stretch version or latest. It's 941 megs. So you can see just by that, the container, the application size that you're gonna end up deploying is gonna be very different, right? Again, I keep mentioning this is the size on disk. This doesn't respond to, say, number of network requests or number of RAM usage or something like that. Now, within this itself, depending on how heavy your application is and whatever you're running on top of it, it can consume a lot of resources. So currently, like in my current job, the server I'm using only has 2 gigs of RAM. So will you consider that as a normal server or a standard server? So I don't know, right? But that's enough for me to deploy my application, and that's good enough. And it really depends on the use case. My computer itself is a lot powerful than my server, which is usually not the case, I guess. So it's really more of like, the more you use it, the more experience you gain with it. You kind of get a feeling of like what kind of memory allocation you need. And on top of that, you also can always profile your applications, and you can always profile your memory usage, right? So, okay, so this is a Windows machine, so I can actually just go to my task manager, and I can see, hey, what are the resources that I'm using? And this is actually how you see, like on your server, what percentage of the server is being used, and is it good enough to support your application? For Linux machines, you end up using something like top, I guess. Or, yeah, I think it's top, right, if I remember right. Or like other tools. Yeah, but I don't know if that answers your question.
Yeah, indeed. Thanks a lot.
No worries. Can I ask you, like, if you don't mind, like, what's your background though? Like, when you started out, did you already know how to use Docker, or is this your first time looking into it?
I think I started on it quite recently. I was just because previously I was writing some Python scripts and was trying to deploy to a server. So that's where I realized Docker could help to standardize like the dependencies and make it easy to deploy.
Yeah. So in my application, I also end up using Python a lot. So when I'm deploying, I'm usually deploying, as in my backend is on Flask, and I end up using like Unicorn to run my server, right, on the application. It really helps with Python specifically because the dependency is kind of annoying to deal with. So you have your virtual env and your like local environment. I end up using like Conda for package management, but you don't have to worry about that at all when you're working with the Dockers.
Yeah.
So yeah, that really, really helps.
I saw there was a question from Alok. What's the difference between Docker Compose and Docker Stack Deploy? I don't know if Alok is still connected. No.
He is not actually. My understanding of that, I think Docker Stack Deploy is part of Docker Swarm, which I have not explored yet.
Yes.
So I can't really say much. But for those of you who are curious, the difference between Docker and Docker Swarm is the same as like Docker and Kubernetes. So whatever I'm showing you right now is all in only one machine. So imagine you have multiple machines, right? And among those multiple machines, you are deploying your applications and you're scaling horizontally across all those different servers. You need to be able to manage it in a certain way, and Docker doesn't provide it out of the box on its own. So the community came up with like different tools on top of that called container orchestration tools. So you kind of like orchestrate how all these different containers can be managed across different machines as well.
All right. Is there any questions from anyone else? Or...
What's the universe?
42.
Yep. Thank you very much. Thanks, Drew, for running this course. It was really, really interesting. And I really liked all the questions that we had as well.
Thank you everyone for joining. So I'm going to end this session now, if everyone's okay with it. And I'll try
Thank
to
you.
see if there is possibility to that. Okay, cool. So yeah, bye guys. I gotta go
Bye.
have dinner
Bye.
now. Ciao.